Hey biology students, so today we are going to talk just a little bit about test crosses. All right, I have a copy of these notes that are in Google Classroom, so I'm just going to kind of go through them with you. I don't have any big huge worksheet to go with this because this is just kind of a minor topic. It'll show up in your packet maybe once or twice, and I just want you to be aware of it. I don't know if I'll give you any big huge question that would be on the test or anything like that, but I just want to kind of explain what a test cross is to you, okay? All right, so I'm going to go ahead and point down and we're going to take a look at these notes, and you should roughly have these notes in your Google Classroom so you can kind of follow along, all right? So a test cross is if we want to know what an unknown could possibly be. Well, an unknown has to be probably dominant, right? Because a dominant can be either homozygous dominant or it can be a heterozygous. And see, we wouldn't know the difference because both of these would look the same. So in the case of, say, pea plants like tall and short, see, you could have this or you could have this. So what we do on a test cross is we cross the unknown with a homozygous recessive. All right? So the reason why we do that is because if you cross it with a homozygous recessive, we know what the genotype, we know what the alleles are for a homozygous recessive. All right? In our results, if some of the offspring exhibit a recessive trait, then the unknown was heterozygous. So we go down to here, and here's homozygous dominant, and here's heterozygous. So you see that heterozygous, and you can see that in this possibility, we have a 50% chance of tall and a 50% chance of short. So in this case, if you get a result like this, then you know it has to be heterozygous. You come over conversely, if all the offspring exhibit dominant phenotypes, then the unknown had to be homozygous dominant. So if we get this, where all are tall, 100%, then the unknown had to be dominant because this is the only kind of option we get. All right, that's kind of how we do unknown genotypes. So you would basically, let's say you have a tall plant. You want to know, hey, I wonder if this tall plant is homozygous dominant or is it heterozygous? So then you take and you cross it with a short plant, and then you see what kind of plant you get as offspring. If you get some short and some tall, then it was this. If you get all tall, then it was this. All right, so we'll just do a quick example. All right, so here's the example we're going to do. All right, it kind of got cut off over here, but I think you guys have it all in your handout. So in sponges, yellow is dominant over white. Well, clearly SpongeBob SquarePants is dominant, right? He's yellow. So it says, what are the possible genotypes for SpongeBob? So I'm going to write my answers over here. Well, if SpongeBob is yellow, well, what could he be? Well, he could be homozygous dominant, or he could be recessive, heterozygous, right? So the next question, it says, to determine SpongeBob's true genotype, what kind of female sponge should he marry and have baby sponges with, called spores? Okay, that's made up. That's not actually a real term. Well, we would want, if we wanted to know which one of these SpongeBob was, well, it should be two little Y's or a white sponge, right? All right, so for C, it says, after SpongeBob gets married, and he and his wife have 50 spores. So we're assuming that SpongeBob, married the recessive. All right. He and his wife have 50 spores. Out of that, 26 are white, 24 are yellow. What's SpongeBob's genotype based on this? Well, based on our original conclusions, and I'll just kind of pull it down and we'll look at it. If some of the offspring show a recessive trait, then had to be heterozygous. Well, we got 26 white, 24 yellow. So we're gonna assume SpongeBob's that. It says, why did you choose that genotype? Show at least one Punnett square to go with your explanation. All right, so I'll put D down here. So here's what I'm gonna do for D. I'm gonna say SpongeBob was this. That's SpongeBob. And I'm going to say Mrs. SquarePants is two little Y's. So then we get something that looks like this. And then we would get a Geno of 50-50. And we would get a Pheno of yellow 50% and white 50%, which is clearly pretty close to what we have in the problem. Okay? All right. So what I would do if I was you, I would hit pause and do this next one. So pause the video, do this next one, and then I'll show you how to do it. All right. So now that you've done this video, or if you didn't, now we're saying in starfish, pink is dominant, the recessive color is yellow. So we got pink, dominant, and we got yellow. It is obvious that Patrick starfish is pink. What are the possible genotypes for Patrick? All right, so A, Patrick can be heterozygous, or he can be that. B, to determine Patrick's true genotype, what kind of female starfish should he marry and have baby starfish twinkles? That's a made-up name, not real. All right, he should go yellow or two little peas. That's if we want to know what he is. All right, Patrick does get married. He and his wife have 25 twinkles. Out of that, all 25 are pink. What is Patrick's genotype based on his kids? Well, if they are all pink, then based on my conclusions, if all the offspring exhibit a dominant, then the unknown was homozygous dominant. Well, then they are. I'm going to say Patrick's two big peas. All right, D, why did you choose it? Show a Punnett square. All right, so for D, I think Patrick is this, two big peas. I know Mrs. Starfish, Patrick Star, is two little peas. Therefore, I would expect my probability in this matchup to be 100% heterozygous and 100% pink, which is exactly what we got. All right, now, on your notes, there is a third example for you to work out. All right, so work out that third example, and then we'll see if you get it right. I will submit some answers to you, or better yet, I might give you a place to share that in the notes. Okay. All right. Well, take care. That's Testcross. Enjoy.